Given the coordinates of a figure, how can we determine the properties of the figure and confirm each property algebraically? We're going to focus on two formulas. The distance formula will allow me to determine if my figure has congruent sides, because the distance formula will determine the distance between the endpoints using those coordinates. I can find the length of each segment of the figure. Since we are given 4 coordinates, we have a quadrilateral creating line segments AB, BC, CD, and DA. We'll also use the slope formula to identify parallel or perpendicular sides. In many of our quadrilaterals, we can prove opposite sides are parallel by comparing slopes, or we can prove adjacent sides, two sides beside each other that meet to form an angle. Those adjacent sides, we can prove if they are or are not perpendicular, telling us if there is or is not a right angle. Right angles being characteristics of many figures, like a square has right angles, whereas a rhombus does not. So you can see how both the distance and the slope formula will be required. Look at what they have in common. They're both using change in y and change in x, just in a slightly different way, to be able to determine the slope and the distance between those endpoints. So if we take two coordinates like segment AB and we apply the slope formula, we're doing y sub 2 minus y sub 1. Y sub 2 is my second y value for point B, y sub 2. And y sub 1 is my first y value for point A. So 2 minus negative 2 is divided by x sub 2, so that's the corresponding x value for B. X sub 2 would be 5, minus x sub 1 would be negative 1. And that's the computation we would use for the slope formula. Looking at that in the distance formula, we're going to do the square root of that same answer squared plus the other answer squared to get the distance between the endpoints. So when we do this computation, we know we're also getting those answers that are going to be applied in the distance formula. So y sub 2 minus y sub 1, 2 minus a negative turns into 2 plus 2, which is 4. So I can go ahead and say that y sub 2 minus y sub 1 in the distance formula is 4, over x sub 2 minus x sub 1 to find slope. 5 minus a negative 1 is 5 plus 1, which is 6. So that would be the same value that we put in the distance formula. The slope can be simplified, but make sure you use the numbers you get from the original computation in the distance formula. But look back and see, is the slope positive or negative? Since both numbers are positive, a positive divided by a positive is a positive, and it can be simplified since both numbers are divisible by 2. When I divide by 2, I get a slope of 2/3. And when I simplify the distance formula, I need to square those values. 6 squared is 36. 6 times 6 is 36. Plus 4 squared is 16. And then your last step with the distance formula is taking the square root. After I add 36 and 16, I get 52. So the square root of 52. That can be simplified because it's divisible by 4. 4 times 13. And the square root of 4 is 2. So 2 root 13 would be the simplest form. Pause the video and finish the chart, finding the slope and distance for each pair of points. Once you find the slope and distance between points for each of your 4 segments, you now can compare and determine what properties exist. Seeing that all 4 sides have the same length, we can think of a square or a rhombus because those are quadrilaterals where all 4 sides have the same length. In both of those, opposite sides are parallel, and our opposite sides would be AB and CD, and we see they have the same slope, proving that they are parallel, as well as BC and DA. BC and DA have the same slope, proving that we have 2 pairs of opposite sides that are parallel and congruent. That excludes a trapezoid, since a trapezoid has exactly 1 pair of parallel sides, opposite sides that are parallel, and 1 pair that's not. So we know this is either a rhombus or a square. Now, how do we know the difference there? We have to think about the type of angles that are specific to squares only. Squares have right angles. Right angles are formed when 2 lines are perpendicular. 2 lines are perpendicular when their slopes are negative reciprocals. So we can prove with slopes that line AB is perpendicular to line BC because the slope of line AB is 2/3. The opposite of that is a negative. The reciprocal is 3/2. So given that these 2 lines have slopes that are opposite and reciprocal, we can also prove that the figure has right angles. If you go through, you'll see that that relationship exists between every pair of adjacent sides. So opposite sides are parallel because the slopes are the same. Adjacent sides are perpendicular, forming right angles because the slopes are negative reciprocals. All side lengths are equal. We've proved the properties of a square.